This was actually the last thing we explained, the context of the cryptography. We finalized we saw the basic and the very famous scenarios behind the cryptography. We defined the symmetric and the conventional cryptography context. We saw the actors, the main actors in that. We defined the standards utilized for generating ciphers and for making encryption and for making decryption. We saw the definition of the public and private keys utilization. We saw the standards utilized for generating public and private keys. And we saw some contexts in securing cipher submitted through the network remotely. And we saw the context of how to secure even the communicated keys publicly using the digital envelope, regardless. So all of this actually we passed through. We finalized this context of cryptography. So if you do not have any upraised questions from this unit, we'll pass to the to the next unit, which is the authentication. Which is the authentication. Shall we? Are you able to see the new slide, please?
Yes, Mr.
Yes, that's good. That's good, Musab. So, as per the as per the first definition of what is authentication, we just remember and we come back to the same definition we saw chapter number 7, digital security from the ITA, from the computer security course. Authentication is a context of proven an ID, just versus an object versus a system. Let's say means you as a subject, you as a user, if you are willing to utilize any digital system, let's say the ED-Wave, our ED-Wave, you have to prove your ID in order to give you access to some resources, to dedicated resources. Your ID is the username and password mainly for the ED-Wave. So if your username and password are correct, so you'll be awarded an interface with some services dedicated for your session. This is the context of the authentication. So when you as a user, you log in and you succeed in logging in, you've been authenticated to the system versus the system. The system is the object. You are a subject. The interface where you input the username and password is the authentication phase, is the context to prove your ID, is to give you a dedicated session to utilize the services inside. And the proof of that is that the same interface is given to you as a student, it is given to me as an instructor, it is given to the administrators in the administrative, let's say, department, and each would see different services, different functionalities to do. This is why, this is because of the session activated, because of the user, let's say, role. There are scenarios behind to authenticate. It's not one technique, it's not one standard that we have to follow once for all. No, there are means to authenticate users, and based on those means we specify later on the resources to be delivered to the end users. All what I just said right now, it is defined in the context of the authentication. Objectives of this this course, actually, we see as an overview, as I said, this is the authentication context. We are going to see all the details. For the objectives, we discussed the context of how to authenticate, how to prove your identity scenarios, mechanisms, how we are going to deploy the authentication scenario, mainly the very basic one, and it's the very weak scenario, which is the username and password scenario, utilization to authenticate users. It's the very weak, yes, and it's the very persistent. Why? Because applying an authentication scenario, it's not something that you choose by your wish or your understanding only. There are criterions you have to go after in order to decide to use the mechanism number 1 or mechanism number 2 and so on. Based on some criterions, we decide. Talking in context of budget and the financial aspect, the password-based authentication systems, they are the very cheap, they are the very easy to implement and deploy. Thus, they are very successful up to date. While they are Very weak means we can break those systems. We can attack and find vulnerable aspects in every single password-based authentication system. This is for sure. Thus, we have to understand that there are constraints we have to consider in order to decide to follow which mechanism. What are the mechanisms actually we are going to see one by one in this chapter, no more or less. Starting, starting by defining and giving the first definition to what is actually authentication. Remember that there are actors behind the authentication scenario. We are talking about the user authentication. User authentication. So it is a matter of identifying and proving the identification. It is a matter of identifying and proving the identification, no more, no less. A user is a subject. He is the one willing to utilize the resource. So identification means you specify your ID. Who are you? Who are you? And then after to prove that versus system, it is a context of authentication. We saw this actually, but let's go a little bit faster. The actors mainly in an authentication context is the claimant, the verifier, and the relaying party. Claimant is you as a user subject. Verifier is one to give you yes or no, permittance or denial to access the system, do not access the system. Is the party to responsible for verifying your ID. Verifier. The relaying party, it's from where the verifier will seek for your ID and seek for your, let's say, trust level in order to give you the access. The relaying party is the party where you are registered, you as a subject, you as a claimant. When you claim means you are registered. Where is your records, or where are your records? They are here in the relaying party, something like that. So a graph to demonstrate all of this. You are a claimant, actually, you are the core of the authentication. You as a subscriber, you as a user, you as a subject, you are the co-actor of the scenario of authentication. This is a full authentication mechanism. You subscribe at the beginning, so you have been registered. You have been registered in a registration authority, and your credentials have been actually saved somewhere, which are your credentials, in plural, managed by a credential service provider, CSP, sorry, and those credentials here, they are utilized once for all. Means whenever you try to seek for them, they would be provided to you, or your profile details. You see them and you update them whenever you need. Later on, after 1 day, after 1 month, after 1 hour, after whatever period of time, whenever you come back to the same system and you try to log in, you do not need to register again. Nope. You go immediately to log in. To log in, the verifier would check up if your records here, if your records are available or not. Once yes, available and verified, so the relaying party will act and give you yes the authentication, let's say, session, something like that. So you have been awarded an access to the system, to the environment. Authenticating a subject versus system, we said, and here we repeat again, you have to utilize a mean, let's say a tool. You have to stand on something. To be authenticated means you know something, or you possess something, or you are something, or you do something, or you do all of them, or you are the four of them. You know and you possess and you are and you do, or some parts of them you know and you possess only, or you know and you are something, or you do and you are something. Depends. So, but at least the minimum requirement to authenticate, to be authenticated, you use one of the means here. Either you know something, or you possess something, or you are something, or you do something. One of them at least, or the totality. It depends on the context of the system, the environment you are trying to be authenticated for. One only can be utilized, or all of them combined. Remember, those are means to authenticate, but they are not given 100% security. Still, we have issues to face. Still, whatever the standard, even we apply it perfectly and with 100% proficiency, still will face issues. Good. As we discussed the level, unit number 2, the cryptography level of the harmness that might be applied and caused by a malware, something actually negative. Still, we talk about the level of the authentication versus a user. The level of authentication versus a user means we talk about the assurance. The assurance here. Are you trusted? Means actually you have been awarded an access does not mean that you are trusted. Still, there is a level of assurance here that we have to discuss. Actually, it's a common sense here. Either a little bit you are trusted versus the system, little bit, or you are trusted, some confidence. Okay, you are trusted, or highly confidence. So here we are just given a full trust to you, but there is a fourth level which is fully confident or fully very high confidence, means you are having a full access to the totality of the services available in the system. Here we may translate them differently because this is a common sense of understanding. When you say little confidence, can we measure that? No, no, no. We cannot measure. What does it mean little confidence? Little bit. You are confident, little bit only. What does it mean? This is not measurable. But when I give you the following statement, you are only awarded an access to read forum submissions. This is measurable. This is little confidence. The function given to you is only to display and read submissions. So this is a little confidence. But if I give you the following statement, can access, can retrieve, can edit, can delete all the services and all the resources available. What is this? This is a very high confidence, and this is measurable because you can display. This is measurable. Can edit. This is measurable. Can delete. This is measurable, and so on. So based on the action, we specify the level given to you, the level of the assurance given to the subject in question. Yes. Those are levels. Those are levels given to assure an authenticated party, a claimant. But beside of that, the potential impact caused by such level is subdivided into three groups. Each of them would be, let's say, causing an impact, having an impact onto the system, either a low impact or a moderate impact, or let's say high impact here, impactful. Actually, it's a high impact, may he say here, high impact. So they are actually results of a level or two, results of group of levels, whatever, results to the assurance level. Impacts of the assurance level. Let's have a look graphically to this saying here. We have assurance levels, 4 levels, and we have 3 impact levels. And there have to be actually relationship between all of them. There is a matter of understanding here. Those are some sayings, those are some givens. Here, those are some givens. And we have actually the assurance level, which they are 4, low, some, high, very high. Low, some, high, very high. Actually, since the impact is they are 3 only, we have only the low, moderate, and high. They are 3 only, so we are representing the assurance level with either low or moderate or high. They are 3. When you talk about the impact, we take the example. For example, I want to take the example of the. It's a common sense. It's not technical here. You have to understand, and based on that, you assign. Means if you change this one, for example, the low, inconvenience, distress, or damage, standard reputation, it is yes for the low impact. No, it's not matching, but it is yes matching for the. It is because we talk about the damage. Remember here, it is yes here. It is stressful here. We stress on the very high. Yes, absolutely true. Yet it means it validates the profile. It validates the profile here, the low impact. Sorry, the very high trust. It validates the high. It validates the sum. Let's say assurance, the sum little bit, and it validates the little bit of assurance. All of them. It is from the top. It is a context of understanding, no more, no less. So here it is a matrix that matches the impact of an insurance level based on a statement, based on the reading or understanding on a statement. Password authentication mean is the first mean authentication we define. Widely used, very weak. We utilize very simply and easily username and password. It is said to be a login, identified login name and password. The system would do actually a simple comparison with the ones given by the user in current time and lifetime, and to the ones stored in the CSP, actually yes, in background. Actually, the registration authority has stored your credentials somewhere when you registered at the earlier time, so they would be utilized by the system to be compared for a comparison. If yes, validated, so authenticated. If no, no, you'll be rejected with an error message. Issues versus we'll come to the issues. Actually, yes, exactly here. Uh, Remember that the two attacks we set for the cryptography, the brute force and the dictionary attack, they are still valid for some scenarios, the brute force mainly, because we are going to compare. We're going to make the system do the thing automatically to compare a list of passwords to what the system has in his background. So it is something like that. Offline dictionary attack, it is one of the comparison scenarios. Absolutely true. Means there will be a try to log off the system from let's say, like, I give you the example. What does mean offline? The operating systems we utilize here in University of Nizwa, they are giving you as a student an access. Why? Because they are connected to the domain, to the server, remotely. But if we disconnect each computer, or your computer, the computer utilized earlier, we take off the wire, we disconnect it from the domain, we take off the wire, we take it off, we disconnect fully, and we keep it as a standalone computer. Are you able to log in? Yes, you'll be able to log in as an offline. You'll be authenticated offline with an offline. Actually, you'll be awarded an offline access. This offline access, why? Because the credentials will be compared locally in the computer itself. So those offline credentials, they would be utilized for an offline dictionary attack. Means what the computer has stored, they can be utilized for an attack. Actually, they are a vulnerability. They represent a weakness to the authentication system or mechanism. Specific account attack means we are going to attack the account of Fulan. Ahmed Al-Jabri, we are going to hack his computer today. Yeah, so we attack specifically one specific account. We talk about account, huh? We are not talking about a computer. We are talking about an account. Means a session, is a valid, let's say, yes, account. It's not a computer. It's not a hardware. Okay, like we specify user to attack. Also, there are common and popular accounts that we may attack. Give you the example. Very, it's very common that I give you the example. The routers you utilize you at home to get connected to the internet through the ISP, the internet service providers, or Mental or Naurus, whatever. They all of them worldwide use a same default login credentials, username and password. All of them, they are, because they're commercialized with the same accounts. Those accounts, they may be utilized to attack certain devices, certain, let's say, environments in general. So popular password attack. Password guessing, it's another kind of, it is let's say a dictionary attack. It is a sort of a brute force attack. But here we are just making a small guess. We are making a limit. Not like the brute force, for example, we take thousands in plural of passwords and we make the thing automatic. No. Here we try password number one. It's a guess. It's a play. It's a game to play. If either you succeed or not, it counts on the previous knowledge of the user. This password guessing attack against a single user, it's against a single account. It counts on the previous knowledge about the user, what I know about you. So I have to utilize that knowledge in order to guess what is your password or what is your credential, let's say validity, whatever. We'll see all of them just in order to avoid the explanation of one by one. We'll just have a look at them later on. Later on. Because all of them you know since the computer security, since the digital security course. The countermeasures against such attacks, countermeasures against such, let's say, vulnerabilities, uh, they are policies or politics that you have to set up in order to avoid such behavior, such circumstances to happen. Whenever, for example, in order to avoid the password guessing attack, should I catch the people to do that? No, I cannot even. You as a user, you cannot, a security specialist, you will not be able to do. Remember, we said that cybersecurity, to set it up, it's something difficult, it's not easy. Remember when we presented the mechanism and the standards that we have to go after, the 12 scenarios, these 12 architectures to set up in order to talk about the first security, cybersecurity setup. It's not something easy. And here's an example, password guessing attack. You cannot block such attack. To say that no, I can, no, you cannot. To say you can means this means that you are going to block everybody from trying to guess your account, which is not feasible. It's not something. It's not realistic. Thus, there are measurements to avoid, but you cannot block. Those are some policies to set up in order any of the let's say pre-mentioned those attacks here, those vulnerabilities available against the password-based authentication systems happen, there will be a limit. There will be a limit at least. If they are not stopped or blocked, at least there is a limit for that. It's not easy to do. It's not. They are not those vulnerabilities. They are not exposed from the first view or the first sight. From those measurements, we block the utilization of password file from being utilized by, let's say, as an authentication means by systems. Means the system does not have any chance to use a file, password file or passwords file, to authenticate users. The authentication using a bulk of accounts, no, it has to be blocked. These a policy, these a setup that the developer or the system owner has to do to start limiting the authentication, let's say, vulnerability against the password. Intrusion detection measures. Any trial to access the system without being without being authenticated, there have to be measures to block that. Any trials to access the environment without being authenticated, there have to be measures to block that. Also, measurements to block the account fully block the account. If there are failures, for example, we take the example of the bank Muscat or any bank in here, Sultan Oman. If you just do 5 attempts trying to log with errored credentials, the account fully will be blocked. The full account will be blocked because of the errors. So measurements like this can help limit the hack of the password-based authentication systems. Avoid using, let's say, common passwords. Avoid policies to stop. Means if you try to log into a system, if you try to register to a system, and your registration, during the registration you use, for example, the password ABC123, the system has to reject that. The system has to reject that. Why? Because it is a very common password. You cannot utilize common password because it's easy to guess, it's easy to find. So policies that have to be set there to avoid the usage of the common passwords. Train and enforcement of policies actually usually there have to be updates because those policies, if you set them as a developer day one when the system has been implemented, does not mean it's final. خلاص. No, there have to be actually updates continuously set based on the technological advancements and based on the, let's say, technology setup that the company is updating or just implementing day by day. In addition to that, there have to be actually a control of each workstation, of each computer, of each device utilized to log into a services within the environment. Separately, means there have to be a standalone security to each device. It does not have to be only a one full environment, a full network, let's say, control. No, even a standalone devices, a standalone device has to be actually controlled to have the chance to log out from a session or something like that. The communicated or the shared resources, they have to be actually encrypted when communicated. There have to be a scenario of cryptography. We described what is the cryptography in unit number 2. There have to be a scenario of encryption to all communicated values. Uh, Now, as a conclusion, remember that the password-based authentication system, they are very common. They are really persistent, up to date. They are very old and still up to date. They are still persistent. Yet they are with a big deficiency. The list of problems we saw here, it's only a limit. It's only a sort of listing. It's not the final. There are others, uh, but still it is uh, persistent update. Why? Because as I told you earlier, it is a context of budget. It is a context of knowledge from both sides. Because everybody can utilize the system to authenticate themselves using username or password, but not everybody can utilize a smart card or an electronic radio, let's say, based also smart card to authenticate. Not everybody. Those are dedicated systems and the dedicated users to utilize such environments or environments in plural. Thus, this weak scenario password-based authentication systems, they are still persistent, very common used, very commonly used, and still persistent with this long list of vulnerabilities. Fatma Salim, how are you? Fatma Salim, how are you? Fatma Salim, the third time. How are you? I continue. But I consider you as absent. Context of uh, authentication still a little bit long. The usage of the password to authenticate uses there are scenarios to secure the system that uses the password itself. When we say that we are going to apply group of policies to limit the vulnerabilities, those policies, how to deploy them. There are mechanisms. One of them is the use of hash. Actually, we are going to hash the password in order to utilize inside the system, in order to secure the credentials of the registered candidates. What does it mean? Means the user, whenever he's trying to register, his password will be stored inside the system as a hash. We defined last unit what is the hash. It is it is an alphanumerical, and it is just a value to be extracted from the original media, but we cannot understand it. We as humans, we can read, but it does not have any sense for us. This is the hash. And this hash is not simply calculated like that from the password itself. No, there will be a salt value. There will be a salt value. We define what is a salt. Also, the secret value last unit, sorry, when we talked about the three models, how we communicate secured messages on the network. We add a secret value. The same way here, we add a secret value, which is actually salt, nominated salt, milh, to the original media. And then after calculated here, actually computed here to generate a hash. This hash would be stored inside a database. Would be stored inside a database. The database would hold the user ID, yes, the salt utilized plus the hash of his password with the salt. Stored once for all. Later on, the system, later on the user, once he's trying to log into the system using the same credentials, what would happen? The system will search for the ID. Where is the ID? He will find the ID. Then whatever the password submitted by the user would be recalculated again using the salt assigned. If it matched the new, and then after a hash would be extracted. If the hash generated matches the hash available, then would be an access would be awarded. Otherwise, refutal. ID given. The salt that matches the ID will be utilized and added to the password given. Another hash would be generated using the salt and the password given. If the resultant hash matches the available and stored hash, then an access will be awarded. Otherwise, no. The salt value actually, because why it is actually being integrated here, why it is defined to us here, why? Because the path we may give, the path user can give the following path, for example, numbers from 1 to 9 and letters from A to Z. It's a very long password, but very easy to guess. The system will find it very easy. A simple brute force attack will get it. 1 to 9, A to Z. It would be easy to get. Yet, when we add a system-based value, this would impose extra difficulty to a such attack, brute force attack or dictionary-based attack, or guessing attack even. So the salt is a value that the computer only knows, the computer or the system only knows, the system only recognizes to be added to the password. Even the user, the owner of the password, will not know. The comparison later on to be done when an access is tried by the user is to match the hashes, not the passwords, because even the system will not use the password here to store it or to retrieve it. We will only store the hash and use the hash to compare. The password will not be seen by the internal parts of the system. So a salt value is to impose extra difficulty to complexity to the password in order to make it more secure. And this salt will prevent the password from being implicitly or explicitly being seen by the system or the other users, system users. Yes, difficulty, absolutely true. Then the password, it would be actually, sorry, the salt would be specific and unique for each user. Impossible. He's saying actually nearly impossible, but it is impossible to find the same salt for every and each single for two different users. No, it would not be happening. And this is actually one of the success when we are utilizing the salt. Yeah, here we are talking about contexts where we try to brute force such trial, such secured scenario here. Let me come back here. Actually, there are huge activities to be done by the computer in order to succeed in doing brute force, which is actually not feasible. It will not be easy to do such scenario with a success result or a successful result. Scenarios to generate the hash, scenarios to generate the hash, to calculate the hash or to compute the hash. Last unit we did not define the standards for computing the hash. We defined the standards calculating the keys, public, private, and the standards to encrypt and to decrypt. And now we define a new standard which is utilized for calculating a hash. To generate a hash, and you know what is a hash, we may utilize the MD5, the message digest version number 5, the message digest MD5. It is one of the algorithms, in plural, one of the algorithms utilized to generate hashes for a media, for a given media, and the media, whatever it is, password or text or video or photo or whatever, to generate a hash from a media, we may utilize the MD5. Actually, the MD5, it is based on the text only media given as input. Means we get any text we give to generate a hash from such text or such given data, we may utilize the MD5. It's one of the very successful hash generators. Good. The MD5 is one, as we defined now, the MD5 is one of the very famous standardized algorithms utilized to generate hashes for values. Yet still it is representing some vulnerabilities and some weaknesses because its generated hash might be matched with other, let's say, stored hashes somewhere. The user can have a list of stored hashes of values and he may do matches. So it is a context of it is a vulnerability here if the outcome can be compared with another value. So we are seeing a limitation here. Yet there is another context where we enhance the generated solution based on the MD5, which is the bcrypt. The bcrypt is a context of using the blowfish block cipher. Here, it's another way how to generate a cipher in addition to the hashing scenario. Both of them altogether they are running to generate at the end of the day sort of hash. This action is based on the bcrypt algorithm. This action is based on the bcrypt algorithm. So the usage of the blowfish block cipher generator and the hash algorithm, either the MD5 or whatever. Mainly we talk about the MD5. The MD5 plus the blowfish block cipher generator. Both of them, they are bcrypt. They are done by the bcrypt algorithm. So we may utilize only the MD5 as an algorithm to generate hashes, or we may talk about a more complex and more difficult, let's say more successful in terms of security, the bcrypt algorithm. Yet it is more time consuming. It is more time consuming. Don't say that let's go with this. No, no, no. You have to consider the time to do so. There are constraints to consider. Do you accept those constraints or not? Do your system support such constraints or not? If yes, yes, let's do. Otherwise, you stop at this level. Your names, please. You type them whenever you hear your name. I'll stop here and take the attendance now.